amplifier. Differential amplifier. How the differential amplifier will works like as a op amp differential amplifier. So in today's class we will see the contents of the class is introduction and the block diagram of the differential amplifier, and this will be mainly it will operates in three modes: differential gain, common mode gain, and the common mode rejection ratio, and the different configuration of differential amplifier. So the introduction. So here the differential amplifier is nothing but so the differential amplifier amplifies the difference between two signals, and it can also be called as a differential amplifier. So each signal is measured with respect to ground. So in this differential amplifier, we define three terminologies. Those are the three terminologies are nothing but differential gain and the common mode gain, common mode rejection ratio, common mode rejection ratio. So differential, it name itself indicating that so differential. So here we are using by using BJTs, or whenever we are combining those BJT transistors into a single structure, so that will works like as a differential amplifier. So in differential amplifier we're having two inputs. So we have to the output of the differential amplifier will give the difference of the signal. For example, V naught is equal to V1 minus V2. So V1, whenever we can consider V1 as a 5 volts and V2 as 3 volts, that is 5 minus 3. V1 minus V2, 5 minus 3 is equal to 2 volts. So that difference will be amplified. That difference input will be that difference value will be amplified by the differential amplifier. So that is the function of differential amplifier is to amplify the difference between two signals. So it is the need for differential amplifier in many physical measurement arises where response from DC to many megahertz required. It is also a basic input stage of an integrated amplifier. So it can be used a basic input. The differential amplifier will be used a basic input stage of an integrated amplifier. So this is the introduction of differential amplifier. Differential amplifier. So next one, the block diagram. So how the in block diagram it will consist the differential amplifier is. So we are having the V1 and the V2. So here at the input, so here we get the difference. So before going to a differential amplifier, we get that difference will be amplified. So within this, so here we have to main the components required to a differential amplifier is input voltage, first input voltage and the second input voltage V1 and V2, and at here in between the input and the differential amplifier also we have some amplifiers or some stages to amplify to differentiate the difference from first input to the second input. So that will be amplified by the differential amplifier, and we get the V0. So V0 will be depends on V1 minus V2. V1 minus V2. Here each signal is measured with respect to ground. So a signal aina gani we have to measure with respect to the ground. So here we have the mainly three terms. Those are nothing but differential gain and the common mode gain and a common mode rejection ratio. Common mode rejection ratio. Well, next one, next PPT. So the output signal in differential amplifier is proportional to the difference between the two input signal. So that V0 is proportional or equal to V1 minus V2, where V1 and V2 are two input signal and the V0 is a single ended output. So here the differential gain is nothing but So we having generally the output of the a differential amplifier is V0 is equal to V1 minus V2. But so we are using by differential amplifier, we have another term. So because it will be uh, the operation of the differential amplifier may depends on so that will gives the differential gain and the common mode gain. So in differential gain, in an ideal differential amplifier, output voltage is directly proportional to difference between the two input signals. సో ఇక్కడ మనకి డిఫరెన్షియల్ యాంప్లిఫైర్లో ద అవుట్పుట్ వోల్టేజ్ అనేది ఏ విధంగా ఉంటుందంటే సో ఇట్ ఈస్ ఈక్వల్ టు డిఫరెన్స్ బిట్వీన్ ద టూ ఇన్పుట్ సిగ్నల్. సో దట్ ఈస్ నథింగ్ బట్ V0 ఈజ్ ఈక్వల్ టు V1 మైనస్ V2 and that V0 is proportional to the differential gain. So here the AD represents differential gain. So here AD is the constant of proportionality and AD is the gain with which differential amplifier amplifies the difference between two input signal. So it is also known as differential gain of the differential amplifier. That is AD is depends on V0 by VD. So V0 by this is V0 by, so this overall term we can consider VD. So then the V0 is equal to AD into VD. So we can also write the equation in terms of V0 is equal to AD into VD. So that is V1 minus V2 is the differential inputs. From one input to another input. Another one is common mode rejection ratio. So in differential gain, in order to eliminate the proportionality constant and constant, namely that is AD is included in this above equation. So where V1 is equal to V2, the output V0 must be 0, but the output V0 of the practical differential amplifier not only depends on the difference voltage but also difference on the average common level of the two input signals. So ఏదైతే కామన్ వాల్యూ దట్ ఈస్ ఎప్పుడైతే మనకి ఇంటర్ఫిరెన్స్ అనేది ఇంక్రీజ్ అవుతూ ఉంటో సో దెన్ వీ కెన్ కన్సిడర్ ద యావరేజ్ వాల్యూ ఆఫ్ ద టూ ఇన్పుట్స్. That is Vc is equal to common mode signal is Vc is equal to V1 minus V1 plus V2 by 2. V1 plus V2 by 2. So that is about differential gain. And coming to common mode gain. So in this mode, in common mode, it is applied to the base of Q1, Q2 are derived from the same source, that is V1 is equal to V2. So the signals are equal in magnitude and phase when the input is applied to the base of Q1. So whenever we are applying the input, so then it will be the difference output is almost 0, so that the feedback reduces the common mode gain of the differential amplifier. That means in the common mode we can consider the average of the input, that is an average of the two input signals is called common mode signal. So that will be denoted as Vc. So this common mode voltage is nothing but average voltage of the inputs, that is V1 plus V2. Hence the differential amplifier also produces the output voltage proportional to common mode signals. So then V0 equal to AC into Vc, where AC is the common mode gain. So here the differential amplifier, it also produces the output voltage proportional to the common. So it also produces the differential mode gain and also produces the common mode signal. Then the V0 is equal to AC into Vc. So Vc here, the Vc is nothing but V1 plus V2 by V2. So in differential case, V0 is equal to AD into V1 minus V2. So where AC is the common mode gain, So therefore there is some finite output for V1 is equal to V2 due to common mode gain AC. So hence the total differential voltage is nothing but V0 is equal to AD plus VD plus AC into VC. So whenever we are adding the total voltage or the two terms from the output of the differential amplifier, so we get both the differential mode gain and the voltage and the common mode gain and the voltage. So then we get the total output of the differential amplifier. Clear. So next one, CMRR. So common mode rejection ratio. Common mode rejection ratio. So here the features of the differential amplifier is so it consists of two inputs and one output, and it will be one transistor acts as on. So due to that we are having the high input impedance, and also it can drive more number of stages, that is a low output impedance and high bandwidth, high CMRR, high differential gain and the low common mode gain. So these are the features of differential. That means whenever we are adding the two transistors as a differential amplifiers, so that both the transistors have high input impedance and the low output impedance and high bandwidth and the high CMRR or high differential gain. So this CMRR is nothing but common mode rejection ratio. When the same voltage is applied to both the inputs in differential amplifier mode is said to be operated in a common mode configuration. That is common mode rejection ratio. So మనం ఎప్పుడైతే సేమ్ వోల్టేజెస్ ఫర్ ఎగ్జాంపుల్ V1 ఈజ్ ఈక్వల్ టు 2 volts అండ్ V2 ఈజ్ ఈక్వల్ 2 volts కానీ అప్లై చేస్తే then both the inputs are said to be operated in a common mode configuration. If any disturbance will be occurred within the signals, that means there will be the value will be up and down. So at the time the many disturbance signals or noise signals appear as a common input signal to both the input terminals of differential amplifier. Such a common signal should be rejected by a differential amplifier. So if both the signals are in the same value, if any one of value is decreasing or increasing to overcome that same value, so then the common input signal to both the input terminals of differential amplifier, such a common signal should be rejected by differential amplifier. సో అలా ఉన్న సిచ్యువేషన్లో ఈ డిఫరెన్షియల్ యాంప్లిఫైర్ అనేది రిజెక్ట్ చేసేస్తుంది ఓవరాల్ ఆ మోడ్ మొత్తాన్ని, ఏదైతే ఆ కామన్గా ఎంటర్ అవుతూ ఉందో, దట్ మీన్స్ నాయిస్తో ఎంటర్ అవుతున్న క్వాంటిటీని రిమూవ్ చేసేస్తుంది. And the ability of differential amplifier is to reject the common mode signal is expressed by a ratio called common mode rejection ratio. సో ఇలా ఎలిమినేట్ చేసే క్యాపబిలిటీ ఆర్ ఈ కమాండ్ ఏమంటామంటే, సో యూ కెన్ కాల్ ఇట్ యాజ్ కామన్ మోడ్ రిజెక్షన్ రేషియో. సో ఇట్ ఈస్ డిఫైన్డ్ యాజ్ ద రేషియో ఆఫ్ డిఫరెన్స్ వోల్టేజ్ గెయిన్ టు కామన్ మోడ్ వోల్టేజ్ గెయిన్. So it is the ability of the differential amplifier to reject a common mode signal is defined by a ratio called common mode rejection ratio, and it is denoted as CMRR. And the CMRR is defined as the ratio of the differential voltage gain AD to common mode gain, and it is expressed in dB. So the formula for in decibels, so ఎప్పుడైతే మనం decibels తో మెజర్ చేస్తామో, then we have to write 20 log magnitude of AD by AC. The formula for a common mode rejection ratio for the differential amplifier is, so the ratio of differential voltage gain to common mode gain. So then we get the CMRR, common mode rejection ratio అనేది మనకు వస్తుంది. So these are the three modes that will be operate, that differential amplifier will be operate in three modes. So here we are having types of differential amplifiers. So we are having 4 types of differential amplifiers. So So those are nothing but dual input balanced output, dual input balanced output. So configurations of differential amplifier is the differential amplifier in the differential amplifier stays in the op amp can be used in 4 configurations. One is the dual input balanced output differential amplifier, dual input unbalanced output differential amplifier, single input balanced output differential amplifier, single input unbalanced output differential amplifier. So out of these 4 configurations, the dual input balanced output is the basic differential amplifier configuration. So we అన్ని అవుట్ ఆఫ్ 4లో నుంచి మనం మెయిన్గా ఏది యూజ్ చేస్తామంటే బ్యాలెన్స్డ్గా, అంటే మోస్ట్ పాపులర్గా దేన్ని యూజ్ చేస్తామంటే సో డ్యూయల్ ఇన్పుట్ బ్యాలెన్స్డ్ అవుట్పుట్ డిఫరెన్షియల్ యాంప్లిఫైర్ అనే దాన్ని యూజ్ చేస్తాం. డ్యూయల్ ఇన్పుట్ బ్యాలెన్స్డ్ అవుట్పుట్ డిఫరెన్షియల్ యాంప్లిఫైర్ అనే దాన్ని యూజ్ చేస్తాం. సో దీస్ ఆర్ ద 4 డిఫరెంట్ టైప్స్: డ్యూయల్ ఇన్పుట్ బ్యాలెన్స్, డ్యూయల్ ఇన్పుట్ అన్బ్యాలెన్స్, సింగిల్ ఇన్పుట్ బ్యాలెన్స్డ్ అవుట్పుట్, సింగిల్ ఇన్పుట్ అన్బ్యాలెన్స్డ్. సో బ్యాలెన్స్ ఉంటుంది, అన్బ్యాలెన్స్ ఉంటుంది. అదే సింగిల్ ఇన్పుట్ అయితే బ్యాలెన్స్ ఉంటుంది, అన్బ్యాలెన్స్ ఉంటుంది. సో వాటి స్ట్రక్చర్స్ ఏ విధంగా ఉంటాయి we will see. So these are the circuit diagrams for dual input balanced output differential amplifier. And so in this dual input balanced output, why? So here when based on the name, so dual input. So we are having the 2 dual inputs. So we have V1 and V2 input at Q1 transistor and Q2 transistor. So we are having the collector resistor and the common emitter resistor. So in bit balanced means, so we have to take in between the 2 inputs. That means 2 collectors in between. Whenever we take the output, so in between the 2 collectors of these 2 transistors, then we can call it as a balanced differential amplifier. So that is the meaning of dual input. 2 inputs ఉంటాయి. సో ఎప్పుడైతే మనం ఈ 2 ట్రాన్సిస్టర్ మధ్య కానీ అవుట్పుట్ కానీ కన్సిడర్ చేసుకుంటే, సో మనము ఈ మెథడ్ని, ఈ ఫార్మాట్ని ఏమంటామంటే డ్యూయల్ ఇన్పుట్ బ్యాలెన్స్డ్ అవుట్పుట్ డిఫరెన్షియల్ యాంప్లిఫైర్. So these are useful for to determine the differential voltage gain and the input impedance and output impedance for the dual input balanced output. So and it is also refers how it will be acting, how it will be operating. So that will be determined in input impedance and the output impedance of the 2 transistors. Clear. So next one we will see dual input unbalanced output differential amplifier. So here also we are having dual inputs but the unbalanced. So it will not give the difference between the 2 inputs. So only it will give that means only it will gives the differential mode. It will operate in differential mode. So that's why it will give the unbalanced output. So next category, so it is single input balanced output. So here we are having the single input ఇందులో సింగిల్ ఇన్పుట్ ఉంటుందమ్మా. అండ్ ద balanced is the meaning of the balanced is, so we are taking the output in between the both Q1 and the Q2 transistors, in between the Q1. So these are why we are taking the output in between means, so in order to determine the differential voltage gain and the input impedance, output impedance of the single input balanced output. So here the input impedance is nothing but it can be measured at any one of the 2 terminal with other input is 0. సో మనం ఏదైనా టెర్మినల్ కానీ కన్సిడర్ చేసుకొని సో అక్కడ కానీ మనం మెజర్ చేస్తే we can get the input impedance with another input is 0, and the output impedance is, so it can be measured any one of the collector terminal you can measure any one of the collector terminal with respect to ground. So that value will gives the output impedance. That value will gives the output values. So by using these different categories, so we have to calculate the input impedance and the output impedance and the CMRR and analysis of the circuit in terms of both the properties of differential amplifier. So this is one type of differential amplifier. And the next one, last one, a single input unbalanced output differential amplifier. So whenever we observe the circuit diagram of this one is so here Vs we having the input single input, and the another another input will be grounded. That means V1 minus 0, and we will get only the V1 difference. So whatever the V1 has the noise or common mode rejection ratio, so that will be gives as the output of the V0. So single input unbalanced output a differential amplifier. So these are useful for to determine the input impedance and the output impedance of the specific transistor. So here we have to analyze the operating point. So here we have to analyze for the differential amplifier, we have to analyze the DC analysis and AC analysis. So it will helps to determine the operating point. So the operating point is nothing but so how much voltage that is cut in and cut off voltage, and the threshold voltages are required to arm these transistors. So that will determine the operating point and the equivalent circuit of differential amplifier. So that can be obtained by making and removing the AC sources by using differential amplifiers. That means the DC and the AC components adding and removing will be done by the differential amplifier. So from this presentation we have know about differential amplifiers and its types. So these are, so mainly we having the differential amplifier is nothing but so it amplifies the difference between the two input signals. So that difference will get in terms of three modes. One is the differential gain and the common mode gain and the CMRR gain. So to determine those values, so mainly we are using four type of categories. Those are nothing but a balanced dual input balanced output differential amplifier, and another one is dual input unbalanced differential amplifier. The another one is single input balanced differential amplifier, and another one is single input unbalanced output differential amplifier. Apart from these four, so we have to consider most popularly we have to use the first one is dual input balanced output differential amplifier. So by using these amplifiers, so we have to know that how the magnitude and the phase will coming at the output of the differential amplifier, and we also know the futures of the differential amplifier is nothing but how the input impedance will existing from one terminal to another terminal, how the output will impedance will existing from one terminal to another terminal, and the CMRR and the bandwidth and the gain. So those overall factors will be determined by using these type of transistors. So this is about today's class, and we will see next topic in next class. We will see another topic in next class. So now I am taking the attendance. Okay, thank you for one and all.